everyone, we're going to find all the local extreme values of the graph of f of x equals x cubed minus 3x minus 2. And what we're going to do is we're going to try to find the horizontal tangents, and that's going to help you find the local maximum and local minimum. So if we differentiate our function here, we're going to get f prime of x equals 3x squared minus 3. Now let's simplify this. Factor out of 3, you get x squared minus 1. And then you're going to get, let's expand this, x minus 1 times x plus 1 for our difference of squares. Now for the horizontal tangent, this must equal 0, so I'm going to put this as 0. So we have x equals 1 or x equals negative 1. Now let's find the maximum value and minimum value. So what you do is you're going to take f of 1. When you substitute in 1 into this, you're going to get 1 minus 3 minus 2. And that equals negative 4. So that would be 1 comma negative 4. And at f of negative 1, we're going to get negative 1 plus 3 minus 2. And that's going to give you 0. So at negative 1, we have 0. The problem is finding which one is the min and max. So for this particular problem, at this stage, one way to do it is to graph it. So we already know that we have either at negative 1 it was 0, and at 1 it was negative 4. So what you would do is look at your graph, and we know this is a cubic function that's positive. So for our end behavior, it has this kind of behavior. We start in quadrant 3, end in quadrant 1. So basically what you would do is you'd start down here. Also our y-intercept is negative 2. So you can look at it this way and go down to this one here. And then it's going to go up somewhere here. All right. So this is your horizontal tangents here. So therefore the point let's just look at this, at x equals negative 1, this is a local maximum. And you would say at is 0. And for this point here, this is a minimum value. So this is at x equals 1, the local minimum value is negative 4. If you didn't want to graph it, say you didn't want to graph it, another way to do it is just look at these 2 points here, negative 1 and 1, and do a little sign diagram and see what the behavior of the graph is. So you wouldn't have to actually graph it. And if you picked, so this would be going to negative infinity to infinity. This is your x value. All right, so if you picked a negative 2 and substituted into, let's just put it in our derivative here. Oops, that's the wrong one. It was 3 times x plus 1 times x minus 1. So if I substitute, say, negative 2 in here, well, this is going to give you 3. Well, we don't need the 3. So basically, this is just going to give you negative 2. This is going to be negative times a negative gives you a positive. And that would mean this slope here is positive. And say substitute in a value here, say 0. If you substitute in 0, you're going to get a positive times a negative. So it's negative. That means the gradient here, or the slope, is negative. So if you're starting from positive to negative, that means you're going up and then down. So that would be a local max. And then you could also check 2. If you substitute in 2, you're going to get a positive. And that would be we're going from negative and then back to positive. So you could also do a sign diagram as well. And once you get used to the sign diagram, it goes a lot quicker than what I just did. All right. Thank you. Have a nice day. Bye-bye.